Welcome back to mech200. We've drawn the isometric cube. We're going to draw a dimetric cube. There are very many hundreds, no, not hundreds, tens of dimetric projections. Just finding the rough center of my right side. There are quite, well, there used to be, they're not very, nobody really does this anymore, but for architectural renderings, there used to be very many projection rules, exact angles. I'm looking at the screen, which you can see, 41.5 degrees and all that sort of stuff. We're going to be kind of going with our own sort of quasi-dimetric. The key thing here is, though, that a lot of dimetrics, many of them, have a true shape face, usually the upper face for buildings, things like that. So architects used to use them to show building layouts or building shape, and then show essentially depth from there. So we're going to go ahead and draw this cube. You have some leeway here, but if you want to follow along, I'll try and say roughly what I'm doing. But again, it doesn't have to be exact. We're trying to show the cube, not get too carried away with the exact projection that we're using. So the thing is, on this cube, the shape is square at the top. We do emphasize all these in the isometric, so they all look the same. If you have a perfect cube, the construction is also fairly reasonable, like we saw last time. What we want to do this time is actually emphasize the shape of the cube, the square, and its extrusion or its extension down. So this, I would argue that it's more important to try and show this shape for what it is. Like we can see, we know this is a cube, but it's actually on the page, it's kind of a diamond shape. On this one, we're going to try and show the square. I'm going to go about 15 degrees off the horizontal, and we're going to extend the edges down. This is also going to make it look quite small. So the plan is about 15 degrees. We're going to start by drawing. I have to do this in a certain order because the way I'm standing. Oh, there's the problem. Draw a square, which is the top face of the cube. We're going to draw its depth. We can draw it straight down if we wish. Keeping in mind, we can rotate this cube any way we wish. So always, we're going to come back to that later in follow-on sketches. Whatever this is, half to 2/3, like whatever you wish. A lot of the dimetrics use 2/3. I'm going to go for actually a half. So the length is half. And then, but we still stick with parallel, 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 and parallel, parallel, parallel. We're gonna have the sun in about the same spot. Hopefully you can see what I've been doing here. Drew off the page. We're gonna draw down, and we'll have the same hatching as we did before. This time we're going to be de-emphasizing these away faces in a way, especially this one that's the darkest. So, did I draw that too small? No, you can see that. So, that's the plan. I'm going to start here about the same spot. I'm going to go a little lower because we're having more. This is rotated towards the upper face. So a little bit down and below from the center. I'm going to put 2 dots here. About 15 degrees from the horizontal. So about 15, and just connect those guys together. That's our start. This edge here is vertical. See if we can get that. Now, if you're having a hard time, you can't see the edge of my paper, but it's over here. If you're having a hard time getting it vertical, just help yourself with a little dot. Sometimes easier to line up the ruler with that. And then half. We'll come to that later. How do we find the half? First though, how do I find the square? I'm going to cheat. Here's my end. That's 1 unit. And I don't know where it is, don't care, but I've got a right angle on my sheet of paper here. So there's my angle. Let's see if we can get that off. And this gives me a chance to say, okay, where is it? It's right there. There's our square, so that's our square. Now we could do it again, but this, I don't want to use rulers and cheats too much, so try and get it about right. And like we were doing before, just do a little check to see how you're doing. So there's our square. Now this is an actual square. So this gives us true shape as opposed to this guy. Same scale, you can see it's going to start looking quite a bit smaller. So we get a light, a sort of zoomed in projection in dimetric. How do we get half? Well, that's quite easy. We can just fold our measuring stick over, if I can find it. And then a half is there. If you want a third or 2/3, you can kind of guess somewhere in here. Importantly, whatever you do for one, you have to do on the others. So if I say a half, then I can kind of guess my way in here. Should be parallel. Parallel in space, parallel in the sketch, and then see if we've got it. So there's our half. And coming across here. Same with this guy. Now I'm going half down. This is it can be quite hard because of this close angle here to get this vertical, so we have to be a little careful here. So I tend to hide the sketch with my ruler stick or measuring stick. And then just make sure I've gotten it about right. It's good. So connect these two guys together. And try and get that in one line if we can. There it is. So that's our cube. Thing is, if we look at this and then look at this, this looks strange. But if you kind of ignore that, this turns into a cube. So as we had before, we don't have to discover the faces so much. There's our edges. So in a way, the construction is easier because we don't have to go through all that precision with the equilateral triangles. But we are, and this is important, we are keeping 3 sets of parallel lines for a cube. So parallel, 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 and similarly 1, 2, 3. Our sun's in the same spot, kind of up and above. Don't line it up on this edge. So either have it out here or way over here. This is our light face, darkest, intermediate, same as the other guy. So I'm going to do the top independently this time because we kind of got a feel for this. So let's draw our guide hatch. Now, do I want to do it like this? Why not? If you want to do it the other way, just draw them the other way, simply. And I'm going to draw these guys vertically. So I'm following my edges as best I can. So we'll have a bit of a difference here, but starting here, doing the same, trying to get the same tones back to boredom. Got a weavy line here, so just eat that as we go along. not bad, not ugly, not bad, kind of ugly. This way, on this one, I'm going to go the opposite direction from previously. So before we had done the lines going across on the high symmetric, this time I'm going to try for quite a bit darker because I know it's coming. And I'm also doing the short method, or the short end here. It's a little easier on the construction. So really jamming these quite close together. Not scrubbing, not coloring, but just kind of really close, really tight. But separate lines. So it's not a solid piece of graphite, it's just quite a tight hatch. Some edges visible. So that goes quite a bit faster than our last intermediate. And again, trying to get it about right. There we go. Does it appear as three tones? Right, so for example, you might have, it's fairly good, but one trick or one shortcut is to actually do a little bit of cross hatching towards the end where the dark or the large, heaviest gradation meets the intermediate. So you can emphasize the difference across the edge. We'll be using this more overtly when we're trying to shade organic shapes later, but for now, we can use this to kind of say this is really quite dark. Get some edges in our perimeter. And it's up to you, but again, habits tend to put the corners in even though they're not ultra visible. Again, if you're trying to, for example, this looks too close here, you could add just a little bit of hatching towards the corners just to say that I am darker. It's great for again, for those who are watching that have lots of experience with shading. Don't lose your mind. This is cheating, I know that. But what we're trying to do is show shape, not too worried about everything. Last thing but not least is the shading. If we look at it, kind of step back, we'll notice that because it's not even, we tend to start showing some, like as if the surfaces are a little bit wobbly. We're going to be using that to our advantage later. But again, don't panic too much. Just going to tidy this up a little bit. Ooh, that is one weavy line. So again, you can sometimes get some errors in here. It's not a perfect. Might have to add some graphite back. If you've got a steady hand, you can also just use the edge of the eraser with some care. Again, it's not all is lost. If you make an error, you can always just fix it back up. This side, if you're left-handed, our show is easier, but I'm going to try with my left hand. Now, again, for those who are purists in the shading end of things, we don't have any floor here or no ground plane. So there's no reflections, nothing like that. Smudging is coming later, perhaps. I hate it, but who knows? Everybody loves it. So we'll do that later. But there we go. That's our two cubes. Isometric. And on the same scale, dimetric. Quite a bit smaller looking. So some of the advantages of the dimetric is true shape on the top is a square. You still have the 3 parallel edges, like the 3 parallel edges in the cube. However, it does require the viewer to see things a little bit better, and sometimes they need some help to realize this is a cube. Isometric is more obviously a cube, but the construction is more complex, and as we would go through into more complicated objects, we would end up spending quite a bit of time with complicated construction for things like holes, curves, radiuses, and the rest. Anyway, there we go. Thanks for watching. Over to you.